So today we'll try to complete this colloid chapters. Yesterday we have started this colloid chapters. This colloid chapter from physical pharmacy is very important, and believe me, a lot of times they used to ask question on this colloid chapter. I would like to revise you yesterday's session in a very short. So what do you mean by colloids? It is a biphasic mixture. Colloid means two-phase system. Okay? Colloid means it is a two-phase system, and it is a mixture in which one substance is divided into fine particles or minor particle and dispersed throughout the second substance, and the dispersed system of particles known as a dispersed phase, and it is distributed throughout the continuous phase or dispersion medium, and this mixture is known as a colloidal system or colloidal solution or colloidal dispersion. तो बेसिकली कोलाइडल डिस्पर्शन होता क्या है? इट इज अ टू फेज सिस्टम कोलाइड्स. द टर्म कोलाइड वाज derived फ्रॉम ए ग्रीक वर्ड लाइक अ ग्लू लाइक, जो आपका है ना गम होता है, चिपकाने का गम, ए ग्लू लाइक कंसिस्टेंसी known as the colloids. So it is a mixture of substance, okay? It is a mixture of two phase, so in which one substance is divided into fine particles and they are dispersed into another substance which is in a larger quantity known as a dispersion medium. So dispersed system consists of a particulate matter known as a dispersed phase, and it is distributed throughout the another phase known as a continuous phase or dispersion medium. Now the mixture, this system is known as a colloidal system or colloidal solution or colloidal dispersion. So yesterday I have told you the Graham, okay, Graham Thomas, he classified substance into two type, crystalloids. Crystalloids मतलब क्या? Crystalloids and colloids. Okay. So Graham Thomas in 1861 described, or he has classified the matter into two type, colloids and crystalloids. So on the basis of ability of dissolved substance to diffuse into water across the semi-permeable membrane. तो उन्होंने क्या किया कि बॉस, उन्होंने एक कंपार्टमेंट बनाया ऐसा, यहाँ पे एक सेमी परमेबल मेम्ब्रेन रखा. नाउ यहाँ पे भी वाटर है, इट इज अ वाटर, इट इज आल्सो वाटर. These two compartment, they are separated by semi permeable membrane. This is semi permeable. Now if you add something to this, if you add a salt, sugar, urea, gum to this, what will happen? So here is a higher concentration of salt, here is a low concentration. There is a diffusion of salt from this side to this side up to equilibrium, up to establishment of equilibrium, right? Now such kind of substance, they are known as crystalloids. They are known as crystalloids. Now colloids means when a colloidal substance, if you add a colloidal substance over here in the water separated by semi-permeable membrane, so colloid will not move. Colloid will not move across the semi-permeable membrane. Colloid will not move. Such kind of substance, they are known as colloids. Are you getting or not? So crystalloid or crystalline substances, crystalloid को ही अपन crystalline substance बोलते हैं. And for example like sugar, urea, sodium chloride or salt, sugar, etc. Substances like a sugar, urea, sodium chloride, they can be easily passed through a semi-permeable membrane. ये क्या है? easily pass होता है semi-permeable membrane से. So okay, sugar, urea, sodium chloride, they can be easily passed through semi-permeable membrane. But other substances like glue, gelatin, gum arabic, they will not cross the semi-permeable membrane. Okay, and they are known as the colloids. So other colloids, we have seen the smoke, homogenized milk, fog, ruby-colored glass, etc. So colloidal system or colloidal dispersions में क्या होता है? Colloidal dispersion, they have properties in between the true solution and suspension. So true solution में, in case of true solution, particle size in a range of 10 angstrom to 10 angstrom or 1 nanometer. तो आप याद रखना 1 nanometer. So in the true solution, particle size is 1 nanometer. In the suspension, particle size is more, that is around 2000 angstrom unit or 0.5 micron. तो solution जो होता है true solution, so it has a particle size of 10 angstrom unit or 1 nanometer. but your suspension has a particle size of 2000 anstrometer or 0.5 micrometer. So the properties in between this true solution and suspension. The property between this means particle size in between these two. Particle size in between these two. True solution and suspension. So they are nothing but the colloid, and that's why colloid is the colloid will have a particle size in the range of this 0.1 nanometer to 0.5 micron. Okay, that is nothing but the colloid is nothing but the particle which are dispersed in a dispersion medium having a particle size in the range of 1 nanometer to 0.5 micron or 10 angstrom to 200 anstrometer. They are known as a colloidal solution or colloids or colloidal dispersion, right? Colloidal solution or colloidal dispersion. Now, size and shape of that dispersed particle. Whatever dispersed particles are there in a colloids, colloid में जो dispersed particle होता है, colloid particles they are larger molecule than molecular particles. जो molecule है ना, they are the particles which are larger than molecules. They are too small to be observed under directly microscope. वो molecular particle के molecules से ज़्यादा बड़े होते हैं साइज में, लेकिन इतने भी बड़े नहीं कि अपन माइक्रोस्कोप के नीचे देख सकते हैं. So however their particle size shape it can be analyzed by electron microscopy. Electron microscope जो होता है, so you can observe this, okay, observe the size and shape of this dispersed particles in the electron under the electron microscope. Okay, but by using ordinary microscope you cannot be able to see the particles, right? These colloidal particles may have different size and shape. Okay, more will be the extended particle. अगर particle बहुत extended है मतलब फैला हुआ है, so that will give a greater surface area. Greater specific surface area means larger the particle, it will give larger surface area and larger attractive forces. Greater will be the extended particle, greater will be the surface area offered, or greater will be the attractive force will be there. A colloidal particle in a suitable environment unrolls and exposes the maximum surface area, while a colloidal particle at a adverse condition, at a non-favorable condition, they will roll up and reduces the exposed surface area. So you can see over here different shapes of your colloidal particles. तो colloid में particles होते हैं, उनके shape अलग अलग होते हैं, जैसे circular, flatted वगैरह वगैरह है. You can see these are the different kind of shapes, circular, flatted, etc., or prisms like that. So these are the different shapes for crystals. These are the different shapes for particles in the colloid, है ना? Like you can see over here नीचे. Like particle may be either spheres or globules or short rod or ellipsoidal, then obligate ellipsoids, flakes, rod, etc. Now purification of colloids, we have already seen this purification of colloid. So okay, the colloidal dispersion may or may not have impurity, but may contain soluble or insoluble impurity. Colloidal dispersion जो होता है उसमें soluble या insoluble impurity हो सकता है. Now insoluble impurity अगर है, so insoluble है मतलब क्या, colloidal जो dispersion है उसमें impurities है और वो insoluble है, दिख रहा है आपको ये, तो आप easily filtration के through आप उसको remove कर सकते हो. Insoluble impurity can be removed by filtration. Now many hydrosols means water containing this colloidal solution, lyophilic colloidal solution, water containing lyophilic colloidal solution known as hydrogel. Many hydrogels consist of a low molecular weight water soluble impurities like salt. Salt may create a problem since it may coagulate the dispersion. These dissolved impurities, they are in a smaller molecular size and they can be removed by means of membrane having pore size opening smaller than the colloidal particle. तो इनको क्या करना है, इनको आपको dialysis करना है. You have to do dialysis. Okay. So if water soluble impurities are there in a colloids, and if the impurities having less particle size as that of the dispersed particle, जो colloidal dispersion में जो particle size है आपका dispersed phase का, उसके कंपैरिजन में अगर soluble impurity का particle size कम है, वो आप remove कर सकते हो. You can remove the soluble impurities by different method. That means purification of colloids. So colloidal dispersion will have either soluble or insoluble impurity. So in insoluble impurity you can remove by filtration. Soluble impurity you can remove by dialysis or electrodialysis or ultrafiltration. These three are method. Dialysis means what simply? Simply dialysis. I will explain you simple. Dialysis means removal of your impurity from the colloidal solution by through a semi-permeable membrane. So semi-permeable membrane, mostly the membranes in current use consist of cellulose nitrate. I already taken you prepared from colloidon, then cellulose acetate or synthetic polymer or animal membrane. Those made from a parchment paper. Parchment paper is also membrane or cellophane sheet. These are the names of membrane. मेम्ब्रेन जो सेमी परमेबल मेम्ब्रेन जो यूज करने वाले हैं डायलिसिस के लिए, तो किसका होगा? सेमी परमेबल मेम्ब्रेन कंसिस्ट ऑफ सेलुलोज नाइट्रेट. एक तो सेलुलोज नाइट्रेट का होगा प्रिपेयर्ड फ्रॉम कोलिडॉन, या फिर सेलुलोज एसिड का होगा, या फिर सिंथेटिक पॉलीमर का होगा, एनिमल मेम्ब्रेन हो सकता है. इट इज मेड फ्रॉम अ पर्चमेंट पेपर और सेलोफेन शीट. तो इससे ये बनता है. अवेलेबल फॉर वैरायटी ऑफ शेप एंड गॉजेस एंड पोर साइज. बिकॉज ऑफ देयर साइज, ये जो इनका साइज होता है मेम्ब्रेन का. कोलोइडल पार्टिकल मे नॉट मे बी सेपरेटेड फ्रॉम मोलिकुलर पार्टिकल्स. मोलिकुलर पार्टिकल मतलब it is an impurity. Molecular particles, they are nothing but the impurity. Now colloidal particles may be separated from the molecular particles because of the pore size of this membrane. Okay. Now through this membrane, colloidal particle will not cross this membrane, but molecular particle will easily cross this membrane. So the technique of separation is known as a dialysis, which uses the semi-permeable membrane. The pore size of this membrane will prevent the passage of colloidal particle, but will permit the small molecular weight particles, molecules such as urea, glucose, sodium chloride. So if such kind of impurities are present in the colloid, अगर colloid में यूरिया, ग्लूकोज या फिर आपका सोडियम क्लोराइड का ये अगर impurities है, so you can remove these kind of impurities by using dialysis. Dialysis का principle देखो यहाँ पे मैं, you can see the principle of dialysis. देखो, so यहाँ पे दो कंपार्टमेंट. दिस वन इज नोन एज अ डायलिसिस टैंक. यहाँ पे दो कंपार्टमेंट है. सो देयर इज अ टू कंपार्टमेंट्स. ओके. सो कंपार्टमेंट ए इज देयर एंड कंपार्टमेंट बी इज देयर, राइट. बिटवीन दिस टू कंपार्टमेंट there is a semi permeable membrane. Now in this you have colloidal material. Right. And in this membrane you have water. In this, just you have to pour colloidal material in this membrane, in this compartment. So what, and in this compartment there is a water. So what will happen? So if salt impurities are present in this, and it is here is a pure water, deionized water, right? So what will happen? So obviously here is a no concentration of that salt, here is a higher concentration of that salt. यहाँ पे ज़्यादा impurity है, है ना, impurity है, लेकिन यहाँ पे नहीं. So salt will diffuse through this membrane. Salt will diffuse through this membrane. So you can see over here, अगर colloidal जो particles है, colloidal particle will not diffuse through this membrane, but subcolloidal material or impurities, so they will diffuse through this membrane. And they will come in this compartment, B compartment. Now you can remove this water, you can remove and discard. Again you pour fresh water to this. So again impurity will move to the water to establish the equilibrium, and again you have to discard this water. So such, by using this technique or by using this dialysis technique, you can purify the colloid. So it is one of the purification method for colloid. Colloid को purify करने वाला ये method है ना. Colloid purify क्यों करना है आपको? Because in the colloids impurities may be present. So if insoluble impurity is present, you can easily remove that impurity by filtration technique. But if soluble impurities are there, so one of the method is nothing but the dialysis. Now another method is there, okay, dialysis. Okay. Now this dialysis method is also two, either batch process भी हो सकता है इसका, और continuous process भी हो सकता है. Batch और continuous process. So batch process में एक particular amount of colloid है, वही आपको purify करना है ना. Batch process. Continuous process मतलब क्या है? कितना भी colloid continuously डाल दो, continuously purify होते रहेगा, right? Batch process, continuous process. So you can see over here batch process. So this is a water tank. Now this is a sac made from cellophane, sac made from cellophane, right? Sac of semi-permeable membrane, right? So containing the सोल मतलब क्या आपका colloid containing sac, okay? Sac is made up of a semi-permeable membrane. तो वो sac में पूरा colloid लेने का है और ये water tank में डालने का है. So obviously, so if impurities are there, salt impurity, water, okay, sugar, urea, like, so that impurity will move to the water to establish the equilibrium. So you have to dip that sac with the colloid in the water. So impurity will be, okay, impure salt or colloid. So impurity will be in the water. Pure colloidal particle will be in a sac. So that is the batch process. Continuous process you can see over here. So you have to introduce sole from this side. A cellophane tube is there. A continuous cellophane tube is there. So you have to introduce the colloids over here. Continuously, this cellophane tube is dipped into the water, and again at the another end, at one end you have to introduce impure sole or colloidal dispersion with the impurity, and here you will get a pure dispersion, pure colloidal sole. So impurity will be here. That is by division. So continuous process dialyzer. Okay, the apparatus used for dialysis is known as a dialyzer. ये then electrodialysis होता है, electrolysis. So in case of impurities are low molecular weight salt impurity है, low molecular weight अगर impurity है salt का impurity है, low molecular weight salt impurity EP is there, then you can remove or you can speed up the electrolysis, you can speed up the dialysis process by application of, by application of electric field. If low molecular weight impurities are there, that can be removed by electrolyte, that can be removed or electrolyte dialysis is carried out in the under the influence of electric field. इलेक्ट्रिक फील्ड में डायलिसिस करना है आपको, तो इट इज हेल्पफुल टू रिमूव सॉल्ट इम्प्योरिटीज राइट फॉर ओके. सो इसमें थ्री कंपोनेंट, सो ओके, इंस्ट्रूमेंट यूज्ड और इलेक्ट्रो डायलाइजर यूज्ड, so consist of the three component. So you can see over here, under the influence of applied potential anions will migrate from solution to anode. तो obviously इसमें क्या है कि you can see over here, so electrodialyzer, this component you have to pour impure sole. Impure sole मतलब क्या, जिसमें impurity है ऐसा आपका colloidal dispersion. यहाँ पे second component, यहाँ पे third component containing water. One component is connected with the cathode, and these three compartments are separated by semi-permeable membrane. यहाँ पे semi-permeable membrane है, यहाँ पे भी semi-permeable membrane है. So if you apply electric field, so what will happen, if anions, अगर negative ions है इसमें, so if anions are present as impurity, so it will move to the cathode. If cations are present as impurity, it will move to the anode through a semi-permeable membrane, and this water can be discarded. So that's how you can purify the soul, or that's how you can purify the your colloidal dispersion. Then again, ultrafiltration is also there. Ultrafiltration, right? Ultrafiltration. So solution, okay, solution that can be passed through ordinary filter paper. But when soil is placed in a compartment closed by dialysis membrane, and if you apply pressure, so ultrafiltration pressure apply करना पड़ेगा. Okay, solution can pass through an ordinary filter paper. So that's why soil is placed into compartment closed by dialysis membrane, and pressure is applied. The liquid and small molecules are forced through this semi-permeable membrane, and the colloidal particles are retained over here. इसमें जो impurities है, small molecular weight particle है ना, यहाँ से pressure apply करेंगे आप, यहाँ पे आपका impure सोल है, मतलब colloidal solution containing impurity, यहाँ पे है आपका semi-permeable membrane. If you apply pressure, so small molecular weight impurity medium, okay, or the water, that will be removed, but you will get a pure colloidal particles, right? Electrolyte and water. So it is known as ultrafiltration. It is one of the purification process for your colloidal dispersion. So we have already seen this. I want to show the diagrammatic representation. Now dialysis also occurs in the बॉडी इन व्यू, डायलिसिस बॉडी में भी होता है, अगर जो भी बॉडी में होता है उसको बोलते हैं इन व्यू, वट एवर हैपेंस इन द बॉडी इन व्यू, वट एवर occurs outside the body known as in vitro. So ions of your ions present in the blood, small molecules present in the blood. Okay, so that is a separated by semi-permeable membrane. That is separated by semi-permeable membrane to the tissue fluid. कोलाइडल कंपाउंड ऑफ ब्लड, ब्लड में कोलाइडल कंपाउंड क्या होता है, जैसे फॉर एग्जांपल प्रोटीन्स, प्रोटीन्स ब्लड सेल जो है, ब्लड सेल तो सस्पेंशन होता है, प्रोटीन्स, सो प्रोटीन्स आर नॉट फिल्टर्ड थ्रू कैपिलरीज, कैपिलरी सिस्टम जो होता है उसमें कैपिलरी से क्या आएगा आपको, ग्लूकोज मॉलिक्यूल आएगा, से सॉल्ट आएगा, salt, glucose, water. Proteins are not filtered. So that's why protein in the plasma can be considered as a colloidal system. And other, for example, this is salt वगैरह है इसमें, water. That is a, say for example, that is impurity. So it can be filtered through capillary system. Okay? And this principle is utilized in the development of artificial kidney for dialysis. Next अपन देखेंगे ये part. Application we already covered, so I will not cover application. Classification of dispersed system. Dispersed system three type में, classification of dispersed system. Dispersed system are classified into three types. Right? So molecular dispersion, then colloidal dispersion, and then coarse dispersion on the basis of particle size of dispersed phase. Molecular dispersion जो होता है ना, molecular dispersion are also known as a true solution. इसके ऊपर एक बार क्वेश्चन आ चुका है. Molecular dispersion are also known as a true solution, and they will have particle size in less than 1 nanometer. The particle size less than 1 nanometer. We already seen this yesterday. Less than 1 nanometer. 1 to 0.5 micron colloidal dispersion, greater than 0.5 micron coarse dispersion. बाकी पैरामीटर मैं नहीं लूंगा आज क्योंकि ऑलरेडी देखा है. We already seen this. And types of colloidal system. कितना colloid type होता है? Okay, who classified this different colloids? So Oswald classified the colloidal system in a three part, depending upon the affinity or interaction between dispersed phase and continuous phase, है ना, कि सिस्टम में जो डिस्पर्स फेज है एंड उसका जो डिस्पर्शन मीडियम है उसके बीच में इंटरेक्शन कैसा है. If it is a strong interaction, it is known as a lyophilic colloid. If it is a weak interaction, it is known as a lyophobic colloid. So Oswald, depending on the affinity or interaction between dispersed phase and continuous phase or dispersion medium, classified colloids into three types. So there are three types of colloid. Lyophilic colloid, it is also known as solvent loving, lyophobic colloid, then association colloid, or association colloid also known as amphiphylic colloid. Amphiphylic colloids, इनको ही अपन amphiphylic colloid बोलते हैं और ampholytic colloid बोलते हैं ना. तो तीन टाइप के colloid होते हैं भाई, lyophilic colloids, lyophobic colloid, association colloids, based upon the interaction between dispersed phase and dispersion medium. कि जो पार्टिकल है इसमें, जो सिस्टम है colloidal सिस्टम, इसमें जो पार्टिकल है उसका जो मीडियम है उसके साथ में इंटरेक्शन कितना है उसका. इट इज अ स्ट्रांगली सॉल्वेटेड, जैसे lyophilic colloids, there is a higher solvation, so that's why they are known as a solvent loving. Lyophilic means, lyo is the term for solvent, philic means loving, solvent loving. Lyophobic मतलब क्या, solvent hating. So here is a solvation of material, solution of particles, but here is a dissolution, here is not solution, that's why. So we have seen. Okay, now you can see over here again lyophilic colloids. Lyophilic means, lyophilic salts, they are dispersed and they exhibit a definite affinity for the medium or solvent. Lyophilic colloidal dispersion में क्या होता है, जो डिस्पर्स पार्टिकल है और जो डिस्पर्शन मीडियम है सोलवेंट जो है इसमें ज़्यादा इंटरेक्शन होता है. Okay, so they exhibit a definite affinity towards the medium or solvent, and that's why it is known as a solvent loving or lyophilic colloid. Now if the dispersion medium is water, so the system is said to be hydrophilic. अगर वाटर मीडियम है तो हाइड्रोफिलिक बोल सकते हैं. फॉर एग्जांपल डिस्पर्शन ऑफ स्टार्च, गम एंड प्रोटीन इन वाटर. तो आपको यहाँ पे एग्जांपल याद रखना है. एग्जांपल ऑफ लायोफिलिक कोलॉइड इज नथिंग बट द डिस्पर्शन ऑफ स्टार्च, गम, protein, water. Are you getting my voice properly? It is very important. You have to understand the example. You have to remember the example. क्वेश्चन आता है, ठीक है. Now dispersion of starch, gum and protein in the water is known as a lyophilic colloid. Again ऐसा नहीं, it is not compulsory that a hydrophilic ही only यहाँ पे होगा. So the dispersed particle may be hydrophilic. Hydrophilic means if it is soluble in the water, if it is having more affinity towards the water. It may be lipophilic. Lipophilic कब होगा? If the dispersed particle will have more affinity towards the organic solvents. For example, if rubber is there, if polystyrene is there, so you can make a dispersion of rubber and polystyrene. So you have to disperse in a organic solvents like benzene, okay, benzene, and it is known as a lyophilic sol. In water is used, it is known as a hydrophilic colloid. Now, lyophilic colloids are the thermodynamically stable. इसके ऊपर क्वेश्चन आ चुका है, which colloid is thermodynamically stable. So remember, lyophilic colloids, they are thermodynamically stable. कल भी बोला था मैं. Now they can be easily prepared by dissolving the material into solvent being used. जो भी solvent है उसके लिए उसमें उसमें simply वो dissolve हो सकता है. Okay? And they may or may not have charge. तीसरा ये अपन ने कल डिफरेंस देखा था डायरेक्टली, बिकॉज वो इम्पोर्टेंट है, उतना इम्पोर्टेंट था ना. उसके और भी स्लाइड्स थे, सटी रिवर है, वो आज देखेंगे अपन, ठीक है. सो दे मे और मे नॉट हैव चार्ज, दैट इज नोन एज लायोफिलिक कोलाइड. लायोफिलिक कोलाइड में क्या इंपॉर्टेंट है? दे हैव ग्रेट एफिनिटी टुवर्ड्स द dispersed phase, has a great affinity towards the dispersion medium or solvent. That's why they are known as a lyophilic, solvent loving. Example क्या है? Dispersion of starch, gum, starch, gum, protein in the water. It is known as a hydrophilic colloid because this starch, gum, protein, they are easily dispersed in the water. They will have great interaction with water. Now some substance they will not get interacted with the water because, for example, if rubber is there, polystyrene is there. So rubber, polystyrene, if you want to make a colloidal solution of rubber and polystyrene, so we have to disperse rubber polystyrene in an organic solvent like a benzene, and then it is known as a lyophilic सोल. लायोफिलिक सोल. अगर मीडियम वाटर है तो उसको बोलेंगे, है ना, मीडियम वाटर है तो उसको बोलेंगे अपन हाइड्रोफिलिक सोल. अगर मीडियम वाटर नहीं है, ऑर्गेनिक सॉल्वेंट है, तो उसको बोलेंगे लायोफिलिक सोल. लायो मतलब सॉल्वेंट. फोबिक इज अ हेटिंग, फिलिक इज अ लविंग. ओके. नाउ लायोफिलिक कोलाइड्स आर थर्मोडायनामिक स्टेबल. इसके ऊपर क्वेश्चन आ चुका है, आपको मालूम है, एग्जांपल याद रखना है उसके. अगेन they may or may not have charge. इसके ऊपर चार्ज हो सकता है लायोफिलिक कोलाइड के. whatever particles which are dispersed dissolution medium, that may have charge or may not have charge. Okay, but they are easily prepared by just dissolving they are obtained simply by dissolving the material to the solvent. Now next होता है आपका lyophobic colloids. Lyophobic colloid. Now lyophobic colloid means solvent heating. Lyophobic colloid means solvent heating. So lyophobic colloid. So now lyophobic colloid में क्या होता है कि so they are composed of metal particles. So lyophobic colloids are composed of material having little interaction with the dispersion medium. So the lyophobic मतलब क्या? Solvent heating. तो obviously solvent and जो dispersed particle है उसमें interaction क्या रहेगा? कम रहेगा. There is very less interaction or little interaction between dispersion medium and dispersed phase. Okay? They are also called as solvent heating system, and they primarily due to absence of solvent sheet around the particle. तो देखो यहाँ पे solvation नहीं होता. So the solvent or the whatever solvent or continuous phase is there, so it will not solvate the, it will not solve. Okay, so there is a little hydration or solvation. Let's say there is a less hydration or solvation in case of a lyophobic colloid. Lyophobic. इसमें इंटरेक्शन नहीं हो रहा है ना, तो वो सॉल्वेंट जो है वो पार्टिकल के सरफेस में शीट नहीं बना. सो देयर इज ओके ड्यू टू absence of solvent sheet around the particle. This consists of inorganic, in this type of colloids, lyophobic colloid consists of inorganic particles dispersed in the water. For example, dispersion of gold, iron hydroxide, sulfur, arsenious sulfide, silver iodide in the water. So examples याद रखना है lyophobic colloids. So dispersion of gold, iron, silver, sulfur, arsenic, silver iodide, and in water. These are stable. They are stable because of the presence of charge on particle. इनके ऊपर चार्ज होता है, एंड दैट्स व्हाई दे आर स्टेबल. They are stable because of the charge on the particle. These charges, they are like charges, मतलब सिमिलर चार्ज होता है. जैसे माइनस चार्ज आएगा सिल्वर के एक आयन के ऊपर, दूसरे आयन के ऊपर भी माइनस चार्ज आएगा. They are stable because of now, because of the similar charges there is a repulsion between them, and that's why this soul is a stable. Okay? And that's why due to charge, similar charge, there is a repulsion and no coalescence or caking takes place, right? The dispersion are thermodynamically unstable. These dispersion are thermodynamically unstable. Thermodynamically ये unstable होता है. When water is used as a dispersion medium, the system is termed as hydrophobic dispersion. Because ये particles जो है gold के iron nitroxide sulfur, they are not solubilized in the water. That's why hydrophobic dispersion. So lyophilic colloids, lyophobic colloid, and third is nothing but the association colloid or amphiphilic colloid. You know? So organic compound containing both hydrophilic as well as hydrophobic groups in the same molecule. You know? So they are said to be amphiphilic. तो amphiphilic किसको बोलेंगे? अगर कोई कंपाउंड में हाइड्रोफिलिक ग्रुप्स है और हाइड्रोफोबिक भी ग्रुप्स है. Hydrophobic moieties along with the strong hydrophilic groups known as a amphiphilic. Amphiphilic or also known as a surfactant or surface active agent. They are characterized by having two different region. तो ये जो एम्फीपेल्स होते हैं, है ना, एम्फीपेल्स होते हैं, इसमें दो रीजन होता है. एक होता है पोलर रीजन, जैसे ये, दिस इज द पोलर रीजन, this one is a non-polar tail. So this is a polar head, this one is a non-polar tail. So this is in a one molecule only. That's why they are known as amphiphilic. Okay. Now, if you add this, okay, in a water, if you add this surfactant at a low concentration, a low concentration of surface active in a water, surface active agent in the water, so it will exist as an individual monomer. Concentration अगर कम है तो individually behave करेंगे. Now, if you increase the concentration, so these monomers they will associate, they will form aggregation. Okay, they will associate or they will form aggregation known as a micelle known as a micelle. Now each micelle will have around 50 or more monomers. So detailed about this we'll see in the next chapter known as a surface tension interfacial phenomena. The concentration of monomer, the concentration of the concentration of surfactant, the concentration of surfactant at which there is a formation of association or micelle is known as a critical micellar concentration of the surface active agent. Now you can see, जो भी surfactant है that will be represented as this. उसमें क्या होगा, polar head होगा and hydrophobic tail. Polar मतलब water soluble होता है, ये hydrophobic होता है. Now there will be formation of micelle when if you add a surfactant to a water, initially the molecule of surfactant will behave as a single entity, but definitely if you add or if you increase the concentration of that substance, if you increase the concentration, so there will be formation of micelle. So there are different shapes of micelle. For example, यहाँ पे दिखाया है shapes of micelle. Below the CMC, below the critical micellar concentration, surfactants, okay, the molecule of surfactant are absorbed at a water air interface. Okay. In the amphiphils, in case of amphiphils in water, the hydrocarbon chain face inward into micelle. मतलब जब association होता है तो hydrophobic chain जो होता है, that is a non-polar tail, so that will, you know, that will face, है ना, inward, ये solution के अंदर facing करेगा ये, and polar heads जो है that will face outward. Aggregation of this surfactant also occurs in the non-polar solvent. Polar solvent मतलब क्या, water is a polar solvent. वाटर में ऐसे माइसिली फॉर्मेशन होता है एंड नॉन पोलर में उसके अपोजिट होता है. अपोजिट मतलब क्या, इन द पोलर सॉलिड और इन द सिंपली वाटर, सो हाइड्रोफोबिक टेल्स आर फेसिंग इनवर्ड, अंदर की तरफ हाइड्रोफोबिक, है ना, हाइड्रोफोबिक चेंज होते हैं अंदर की तरफ. पोलर हेड कहाँ पे होते हैं, आउटसाइड, है ना, आउटसाइड. बट नॉन पोलर सॉलिड में इफ यू ऐड अ नॉन पोलर सॉलिड में भी माइसिली फॉर्मेशन होता है, बट माइसिली का शेप जो होता है वो अपोजिट होता है. सो इन दिस केस द hydrophilic or polar heads are facing inward and hydrophobic tails are faced outside. है ना. Amphiphilic colloid और association colloid क्या होता है? So if you add a surfactant in a water, initially it will be a individual molecule, but if you add or if you increase the concentration, what will happen? There is a formation of association, there is a formation of collection known as a micelle. Now the concentration of surfactant at which there is a formation of micelle known as a critical micellar concentration. Critical micellar concentration. Micelle can form in the aqueous or polar solvent and also form in the non-polar solvent. उनका शेप अलग अलग होगा, उनका शेप अलग. So if in a polar solvent, so hydrophobic tails are faced inward. तो अंदर के साइड के ऊपर हाइड्रोफोबिक टेल्स होंगे एंड हाइड्रोफिलिक जो हेड है और जो पोलर हेड है वो कहाँ पे होंगे? आउटसाइड. So hydrophobic tails will face inward, hydrophilic polar heads will face outward in a water, but in a non-polar solvent opposite. So hydrophilic or polar heads will face in a inward and hydrophobic tail will face outward. Are you getting or not? समझ रहे हैं आपको? Hello, am I audible? फटाफट बोलते जाओ आप थोड़ा सा. Amphipiles. So we already seen the example of this amphipiles. Maybe anionic. Amphipiles may be either anionic. Amphipiles may be anionic or cationic. Anionic मतलब क्या? Negative charge. Sodium lauryl sulfate is a anionic surfactant. याद रखो, क्वेश्चन आ चुके हैं इसके ऊपर. It has a HLP value of 40. इसका HLP value कितना होता है? 40. याद रखना है. HLP value अपन नेक्स्ट चैप्टर में देखें. Then cationic surfactant और cationic amphiphile. Cetyl trimethyl ammonium bromide. Non-ionic का होता है एग्जाम्पल polyethylene lauryl ether. Ampholytic का होता है ampholytic is also known as zetorionic diethyl deodecyl ammonio propane sulfonate. Diethyl deodecyl ammonio propane sulfonate. We have already seen this also. Characteristic of lyophilic and lyophobic salts. Difference है ना, ये ऑलरेडी देखा है अपन ने लास्ट. मेथड्स ऑफ प्रिपरेशन ऑफ सोल. प्रिपरेशन मेथड भी अपन ने देखे कल yesterday. In a short, I would like to revise now. So there are two methods basically. First method, okay, basic. There are two basic methods. Okay, first method is nothing but the reduction of larger particle. Reduction of larger particle. अगर particle size ज़्यादा है तो उसका reduction करो by using different technique to a colloidal size. Okay, और another method होता है condensation method. So if particles are already smaller or subcolloidal particles, okay, if particles in the solution are subcolloidal size, then you can condense that particle to become a colloidal particle. दो मेथड होता है, reduction and condensation. Some substances are easily converted into colloids when dispersed into solvent. This dispersion is called as a peptidation. Now, methods for preparation of colloids. Methods for preparation of colloids. So there are two types. Dispersion method. So in this large or macro sized particle are broken down into colloidal size. Aggregation method is also known as a condensation method. And in these particles of subcolloidal size, they are aggregated or aggregating the ions of molecule, so that will convert into colloidal particle. मेथड भी अपन ने कल देखे, so मेथड के ऊपर आज नहीं एक्सप्लेन करना नहीं जाता, ऑलरेडी ये मेथड कल देखे अपने colloidal मिल. So this one is known as a, ये जो है it is known as a इलेक्ट्रो डिस्पर्शन. इसके ऊपर क्वेश्चन आ चुका है एक बार. इलेक्ट्रो डिस्पर्शन मेथड इसमें क्या है? ब्रेडिग्स आर्क मेथड, also known as a Bradig's arc method. इसके ऊपर क्वेश्चन आ चुका. Bradig's arc method is used for preparation of colloidal dispersion of metals. Bradig's arc method is used for preparation of colloidal dispersion of metals. तो आपको लिख के भी लेना है कुछ पॉइंट्स. अभी तो ये ऑलरेडी हो चुका है, इसके लिए नहीं, लेकिन जो अगला वाला पार्ट होने वाला है ना, तो जो सेकंड एक सेविंग करके बाद में जो होने वाला है वो इंपॉर्टेंट पार्ट है अगेन जाना, उसके ऊपर आपको नोट्स भी लिखना है. ठीक है. तो व्हाट हैपेंस इन दिस केस, इसमें क्या है, इसमें देखो यहाँ पे मैं एक्सप्लेन करता हूँ थ्री थ्री पार्ट छोड़ो। ब्रेक्स ओके प्रेडिक्स आर्क मेथड, प्रेडिक्स आर्क मेथड में क्या है? सो हियर इज अ metal, here is a metal sheet, is a metal sheet, and it is supplied a current high a voltage source, a source of high voltage, okay, ये connect होता है cathode and anode से, anode and cathode. Now it is dipped into the water, ये सब क्या है? water है, and it is a water, okay, deionized water with traces of alkali, alkali होता है यहाँ पे KOH, KOH पोटेशियम हाइड्रोक्साइड का यहाँ पे अल्कली होती है, traces of KOH, okay, KOH. If you supply current to this, ये जो water है, it is a in a cold, it is in a ice bath, cold water होता है, ice bath में होता है. Now if you apply a voltage over here, so what will happen? Due to continuous spark of positive and negative, you know, current, continuous spark on this metal sheet. So metal sheet will be heated. And there is a release of particle. यहाँ से पार्टिकल रिलीज हो जाएंगे मेटल के, जैसे सिल्वर है तो सिल्वर पार्टिकल्स, गोल्ड है तो गोल्ड पार्टिकल्स, है ना. सो दैट पार्टिकल्स दे आर इजीली एडसॉर्ब्ड इन द वाटर, बिकॉज ये वाटर क्या है? कोल्ड वाटर है, एडसॉर्ब वाटर, एंड यू विल गेट अ कोलाइडल डिस्पर्शन, दैट इज अ ब्रेडिक्स आर्क मेथड, ठीक है. और तीसरा मेथड होता है पेप्टाइजेशन. थर्ड मेथड इज नथिंग बट पेप्टाइजेशन. थर्ड मेथड होता है पेप्टाइजेशन मेथड. So peptidation means it is opposite to the coagulation. होता है कि freshly precipitated ionic solid, freshly precipitated ionic solid, कोई भी solid है जो इसका precipitate हो चुका है, जैसे फॉर एग्जांपल फेरिक हाइड्रोक्साइड, इसका precipitation किया आपने सिंथेसिस करके. So there is addition of small electrolyte. The small quantity of electrolytes is especially common ions. They are incorporated to stabilize the system to prevent the coagulation. So that's how you can get a colloids. तो प्रेसिपिटेशन करने के बाद इमीडिएटली उसमें कुछ सॉल्ट ऐड किया करेंगे, ताकि वो मॉलिक्यूल जो है वो एक में के साथ एग्लोमरेट ना हो सके, एक में के साथ फ्लोकुल्स ना बने, एक में के साथ, है ना, एक में के साथ बिल्टअप ना हो जाए, तो वो साइज ना बढ़े इनका. इसलिए क्या है कि एक सॉल्ट यूज करना है आपको कॉमन आयन का, एंड इट विल प्रिवेंट द एग्रीगेशन ऑफ precipitate, and that salt is known as a peptizing agent. That salt is known as a peptizing agent. और इसके ऊपर क्वेश्चन आ चुका. What is a peptizing agent? Peptizing agent means to prevent the association of precipitate or to make a colloidal dispersion. Salt, a common salt is added to prevent the aggregation of precipitate, known as a peptizing agent. Now this prevent the coagulation of particle. एग्जाम्पल दिया है, फ्रेशली प्रिपेयर्ड फेरिक हाइड्रोक्साइड जो है उसमें फेरिक क्लोराइड का सॉल्ट ऐड करते हैं टू प्रिवेंट द एग्रीगेशन. सिमिलरली सिल्वर क्लोराइड कैन बी कन्वर्टेड इनटू डिस्पर्शन बाय एडिंग द हाइड्रोक्लोरिक एसिड. क्लोराइड इज अ कॉमन आयन, है ना. दूसरा मेथड होता है कंडेंसेशन मेथड. सेकंड मेथड इज अ कंडेंसेशन मेथड. मिल्क ऑफ ए मिल्क इज अ कोलोइडल डिस्पर्शन ऑफ ऑयल एंड वाटर. आपको ये मालूम होगा मुझे. पेप्टाइजेशन का मेथड का यहाँ पे एक्सप्लेन किया है. सेम थिंग, जैसे फेरिक हाइड्रोक्साइड, फेरिक क्लोराइड उसमें एज अ सॉल्ट ऐड करते हैं, एंड इट विल प्रिवेंट द एग्रीगेशन ऑफ पार्टिकल फेरिक हाइड्रोक्साइड. तो ये कोलोइडल सॉल्यूशन ऑफ फेरिक हाइड्रोक्साइड ना. कंडेंसेशन मेथड क्या होता है इसमें? नेक्स्ट मेथड होता है प्रिपरेशन ऑफ कोलाइड. कंडेंसेशन मेथड, इन दिस मेथड पार्टिकल्स ऑफ सब कोलाइडल रेंज, जो पार्टिकल साइज उसका कोलाइडल पार्टिकल साइज से कम है, जैसे फॉर एग्जांपल मॉलिक्यूलर डिस्पर्शन, तो उसको कोलाइड में कन्वर्ट करना है. सो दैट कैन बी डन बाय कंडेंसेशन मेथड. कोलाइडल रेंज पार्टिकल्स दे आर एग्रीगेटेड और दे आर मेड कंडेंस टू पार्टिकल टू फॉर्म ए कोलाइडल रेंज. ओके, जनरली केमिकल रिएक्शन से किया जाता है, एंड फर्स्ट इज बाय एक्सेसिव कूलिंग. सो कोलाइडल सॉल्यूशन ऑफ आइस इन इनऑर्गेनिक सॉल्वेंट्स. अगर कोलाइडल सॉल्यूशन बनाना है आपको वाटर का in inorganic solvent, the colloidal solution of ice in inorganic solvent like chloroform ether are formed at a 0 degree Celsius. At a solution, okay, a solution of water in this solvent on excessive cooling, पहले तो solvent का मतलब ether में water डाल दो and cool करना है आपको. On excessive cooling of this ना solubility will decrease and fine colloidal particles of ice will be formed. That is one of the method. to form a colloidal solution. Another method होता है solvent exchange method. So change in the solvent will lower the solubility. For example, sulfur, phosphorus, they are first dissolved into alcohol, and then excess of water is added to it. So result is nothing but the formation of hydrosol of these substances. You can see over here same thing. This is sulfur, a solid sulfur. Alcohol में dissolve करो आप. So molecules of sulfur in a solution. Then you have to add water. So you need a colloidal particle of change in the solubility, change of the solvent method. Then next होता है आपका method में change in the physical state. Change in the physical state result in the formation of dispersion. For example, sulfur and phosphorus vapors, when they are passed through a dispersion medium containing stabilizer, they will give you a colloid. लास्ट मेथड होता है केमिकल मेथड. केमिकल रिएक्शंस यूटिलाइज किए जाते हैं उसमें. पहला है डबल डिकम्पोजिशन मेथड, उससे बनता है आर्सेनिक सल्फाइड्स डिस्पर्शन. एग्जांपल याद रखना है आपको, ये बाद में मैं नोट्स निकाल के डाल दूंगा आपको, डिटेल में जाने के इसमें there is no need of details. Second होता है ऑक्सीडेशन. Oxidation of a sulfur dispersion can be produced by passing a hydrogen sulfide onto a solution of sulfur dioxide. तो इसमें सल्फर का डिस्पर्शन, सल्फर का सोल बना सकते हो आप कैसे, बाय पासिंग हाइड्रोजन सल्फाइड इनटू ए सॉल्यूशन ऑफ सल्फर डाइऑक्साइड, है ना. इसमें ऑक्सीडाइजिंग एजेंट ऐड करना पड़ेगा. ऑक्सीडाइजिंग एजेंट इज नथिंग बट ब्रोमीन और नाइट्रिक एसिड, दे कैन बी यूज्ड एज ऑक्सीडाइजिंग एजेंट. तो रिडक्शन में भी, reduction is also one of the chemical method में reduction भी आता है. So colloids of metals such as gold, silver, lead, platinum, they can be prepared by reducing agent. Yeah, reducing agent use करना है यहाँ पे tannic acid and formaldehyde. So you will get a colloidal solution, right? Next आता है आपका hydrolysis. Next method is nothing but hydrolysis. Hydrolysis, are you getting or not? Hydrolysis. Salts of hydroxide, iron, aluminum can be prepared by hydrolysis of salt. Are you getting or not? Yes or no? We'll save this once. एक रिकॉर्डिंग से कर लेता हूँ बाद में. अभी इसके बाद में जो है ना वो इम्पोर्टेंट पार्ट होने वाला है.